Hello? Hi, Calgary. We've had to move to a different room, so let me know if the stream is working for you and if the audio is working for you. And we won't start until I get a thumbs up. The computer screen will be on in a second. There we go. And Casey says we good. Awesome. And can you see my screen as well? Move this a little bit. Casey, can you give me one of those? if you can see my screen, awesome, sweet. So that's us. Welcome. It is week 2, day 3. Holy moly! Wow. What? Just zooming through boot camp. Just zoom. You're almost done. Not even close, really. not even close. You got a while. Keep up the good work, but we're not close to finished yet. We are working on something really interesting today. I'm gonna make a new file here. We're gonna call this lecture.md. I'm gonna make this real big. Just want to get your input on this. So this is dark mode. How do you feel about dark mode versus light mode? Dark mode? All right. How do you feel about dark mode versus red mode? Dark mode? How does Calgary feel? We're going to move Calgary over to so I can see your screen here. So red, not a fan? All right, fine. We'll do Kimby dark. Now we'll just do straight up solarized dark. This is good? Cool. All right, so welcome. It is week 2, day 3. It's week 2, day 3. Today's topic is networking, TCP, little bit of HTTP. Right? We'll start off with just networking and TCP. I have a list of things that I want to kind of talk about today. And I have them in this secret notebook. So there's none of this lecture is off the cuff. It might seem disorganized, but it's all scripted. This is all fake. So we got some topics today. Our topics are going to include what is networking. We'll do a little bit of review because I know you've been reading about that a little bit. I think you read a bit about that yesterday. We'll talk about what TCP is, do a little bit of an intro, and we'll talk a little bit about HTTP. And we'll see demos of both. We'll definitely see a demo for TCP. HTTP, we may or may not have a demo. It's really up to how I feel. It's not the point of the lecture today for HTTP. You're going to be spending a lot of time on this for the rest of the program. So I don't want to rush that. TCP though, I want to stress right now. I really want to stress right now. TCP we're doing as a learning tool. Right? TCP is not the stuff that I talk about today is not necessarily stuff that you're going to be doing as a web developer all the time. Right? In fact, you're probably not. But we're going to look at TCP, which is the basic building block of the internet. Right? It's going to be the basic kind of part of the internet. You're not going to be dealing with that beyond today very much. Right? You will have some activities today that deal with TCP. That's cool. But yeah. So I just wanted to make that very clear right off the bat. So if by the end of the week you don't feel super clear on how to use the code that you wrote today for TCP, that's totally fine. That's okay. Use TCP as a way to just start learning HTTP. Now I've just been saying these letters. TCP, HTTP, QM, FM, right? These are just letters. We're going to see what these things actually mean in a second. So I do want to start off with one very big question. So we'll go right here. A very big question. How are you? How are things? That's the big question for today. How's stuff? Is any, like let's do on a scale of big smile to sort of sad to like poop. Like, how are you feeling? The exploding head. All right, so this is Jared. So I think that's the mind blown emoji. Yeah, this one here. So this is, again, Jared, 2019. Right. Again, I want to say keep in touch with your feelings. Alyssa says help. Alyssa, I'll be there as soon as I can. Scott was writing and Scott gave up. I hope you're feeling okay, Scott. I just want to say that, again, these first couple weeks, not super easy, right? I'm very proud of you for getting to week 2, day 3 here. Scott's feeling sleepy. That's good. Make sure you get your 8 hours a night. That stuff is going to be really important later on in boot camp. Do keep an eye on yourself, right? Do keep an eye on yourself. So we'll erase that stuff so that's not in the notes. Today's lecture is about networking. So let me give you some networking tips. First, firm handshake. Firm handshake is the most important part. Make eye contact. Right? Make direct eye contact. What else? Don't talk about politics. Huh? Yeah, say thank you. Yeah. So I wouldn't say thank you. Is that what you said?
Send a thank you.
Oh, send a thank you note. Yeah, send a thank you note. Now, this is networking in real life with people. Not going to be very different from networking between computers. Networking between machines. Networking between machines is going to be built up of a series of protocols and agreements, right? And best practices. Right? So here, send a thank you note. That's a protocol. Right? After you have an interview or whatever, you email them and be like, "Did I get the job?" No, you just say hi. Thanks for taking the time, chatting with me or whatever. Don't talk about politics. That's something we've agreed not to do. Right? Make direct eye contact. That's again maybe something we've agreed to do. Right? So I want you to start thinking about as we go through today's lecture. Networking with machines is like listing out the particular ways that people should be talking with each other, right? We're going to get very, very granular about that stuff. Also, could somebody, so I don't have to keep swiping back and forth, could somebody here watch the Calgary Slack and just let me know if something pops up? You can go to the little plus for channels. Or not plus, rather the word channels, and then search for Cal22. Yeah, Cal22, and it's that one. So networking. I want us to brainstorm a little bit. What is networking? What does it mean? Right, based on the readings that you read yesterday, based on what you know. Personally, what does networking mean? So we got communication, right? Networking involves communication, and communication between whom? Right. So communication between two systems, computers. I'm going to call them agents, or actors, right? Communication between multiple systems or things that, for some reason, need to transfer information between each other, right? So something that facilitates the transfer of information. Right? Ideally, or not ideally, but in like a simple way, one thing that we can think of is A has something, B wants it, and A gives it to B. Right? Some transfer of information. And this idea kind of makes sense? Yeah? Yeah? Cool. Wait, linking the what? Oh, the Game Boy.
And you had to like
Yeah.
link and then your Pokemon.
100%. So here's a like a visual description of that for everyone. So your name was Josh. Was suggesting the Game Boy link. This is very much what networking is. Right? You know, I've got a Pokemon. You want the Pokemon. We link up, and I can transfer over the Pokemon. And the thing is with this, the information has to transfer through some medium. Right? It's not like I could just, all of a sudden I have the information. Right? The information needs to be transferred through something. Right? So when we talk about networking is, by necessity, it's going to need a medium through which the communication can happen. Right? Let's brainstorm on like a couple different mediums or media that could exist. Right? Radio, right? Radio may be a medium. Wi-Fi, right? So we've got like straight up actual physical cable, right? If we said that networking didn't just have to be between machines, we might even say that like my voice and the sound waves, right? Like that could be the medium through which I'm communicating with you. Right? And one that like boiled down though, we have actor A and actor B, and they have to be connected in some way, right? Whether this is a physical connection, right, or an emotional connection, or something, there's got to be some medium that lets messages transfer back and forth. So for today, I'm going to stick with the idea of like a physical cable. Right? I'm going to stick with the idea of a physical cable, very similar to, Casey says copper wire, absolutely. A copper wire. And copper wire is going to be what I mean by like a physical cable. Say that there's something physical connecting two pieces, or two agents. And the idea that I'm going to kind of go with is the like tin can telephone situation. Like, we're going to be thinking of this. Okay? There's two people connected to each other. There's this person here, and then they're talking to this person here. These are going to be our friends today, and they're just going to chat with each other. This image is like tiny. There you go. And they're just going to talk. So this person here can continue shouting into the tin can or down the cable. And this person here can continue listening as long as they want. What can this person here do as well? They can talk back, right? They could also just both shout at each other. And then nobody's listening. They're just constantly just yelling, screaming through this wire at each other. Does that facilitate good communication? Both of them are just yelling and yelling and yelling. So no. So we're going to have to probably come up with some agreement on how the communication can happen through this tin can telephone. Right? You see that the tin can telephone is going to translate almost directly to like web communication. Right? So let me write this up here. We've got a tin can telephone. And we've got two people. We're going to call one person Bradlina, and the other person is Christopheretta. Right? So we've got two people on a tin can telephone having a conversation. Now, Bradlina and Christopheretta can either, like, they can pick up the tin can telephone and just start yelling at each other through the tin cans, or they can meet up ahead of time and draft up a set of rules. Okay. What would one first good rule about how to use this tin can telephone be? One at a time. All right. So here's some rules. Rule number one, we only talk like one at a time. Right. Now, we're going to see that the rules that we come up with for the tin can telephone won't exactly be the rules for web-based communication. But what I want you to be thinking about is just the fact that we have a medium with rules on top of it. Right? Does Calgary have any suggestions for rules that we should be kind of establishing for a tin can telephone line? Or Vancouver, what other rules? Yeah, maybe say over when you're done talking. Right? Say over when you're done talking. So, and then, oh, Casey's typing. Hey, maybe say over when you're done talking so the person knows when they can start talking. Right? It's hard to say, okay, we should only talk one at a time when we haven't established a method for saying when people are allowed to talk. Right? Casey says to make sure no one else is talking by listening before you speak. Excellent. Right. Make sure nobody else is talking by listening before you speak. And that's an excellent rule. Right? Maybe make sure there's nothing coming down the line before I send something down. Right? Here's a super bizarre rule. Bradlina can only talk on like during even minutes, and Christopheretta can only talk during odd minutes. Right? So that way there's no confusion about when I'm allowed to talk. Right? These are super bizarre rules. They kind of really format the way that the discussion is going to happen. But Bradlina can only talk during even minutes, and Christopheretta can only talk during odd minutes. Right? Sure, it gives us a bottleneck as to how fast that communication can happen. But at least by establishing this rule, we've gotten over the interrupting each other thing. Right? You know, say Bradlina and Christopheretta were just very, very fast at talking. I could change this to seconds. Right? And then they'd have to get their communication through as fast as possible. If there was an even minute where Bradlina didn't have anything to say, then Bradlina would just have to wait. Right? Just wait it out. So we can come up with these rules that format the way that our communication is going to be happening. And what we're doing here is we're laying on top of this medium this almost arbitrary set of protocols to facilitate the transportation of messages. Right? So transporting messages over this medium with a protocol. Cool. So, wait, just to check, this is the correct lecture for today, right? I just had it's week 2, day 3. Yeah, okay, oh man. I saw you laughing for a second, I thought. I'm like super paranoid, so I'm just like, oh, I thought I was doing the wrong lecture. I've done it before. So what we have here is a kind of protocol that deals with the transportation. Specifically, it controls the transportation of the messages. What might we call a transport control protocol? Yes, some kind of transport control protocol. I'm thinking TurcoPro, right? Brand new protocol. Nah, it's going to be TCP. So TCP is going to be a set of rules that two machines will have agreed to abide by, right, with how they communicate through the wire. Now, these rules, it's not this. Like the rules that we wrote up, that's not TCP, right? TCP is an actual set of specifications, right? You don't need to learn exactly how TCP works, other than the way TCP works is going to be you can send messages, right? And you can receive messages from someone. So you can send messages to someone, and you can receive messages from someone. And this is going to be as long as you have a connection. So we're going to work today through building up an actual little demo of a TCP server and client. Right? Today I'm really going to be using those words. I'm going to use server, and I'm going to use client a lot. And you're going to see what that means. At this high level, though, do we see a little bit of motivation for why we would want some rules over a medium? Yes? Cool. So TCP is often going to be coupled up with IP. Right? TCP and IP, you'll just see that kind of written all the time. TCP, for our purposes, is going to be a protocol that allows us to transfer data safely, meaning that I can choose to send a message from point A to point B. And with the TCP protocol, there's a bunch of baked-in safety, which we won't learn about, that ensures that a message actually is received at point B. Right? So TCP is going to be a protocol that allows safe data transfer. IP is going to be basically a highway to allow other protocols to get on and find their way to computers. So IP is this, let's call it a big structure that allows any kind of message to make its way down the highway between point A and point B. That's going to be IP for us. It's a very vague kind of notion. IP will allow any kind of messages. Like there's all kinds of messages. I'm going to be using like trucks on the highway as the metaphor for like messages being transported. IP is going to allow any kind of trucks. It might allow like a big semi, right? Like a semi truck, like a 16-wheeler or whatever that like makes it to its destination. It might also allow some kid on a moped, right? Like some kid on a moped with maybe a bag of bagels on his back, transporting stuff between point A and point B. They're two very different classes of trucks. One of them might get tired along the way and just kind of stop for a couple days. So the kid on the moped might have to stop for gas more often or whatever. But at the end of the day, IP is going to let anybody on. Right? Our big semi, that's going to be like TCP. TCP is going to be this very reliable truck that allows messages to basically drive on the highway. Right? Allows messages to drive on the IP highway. And then ultimately what we're going to talk about today as well is this idea of HTTP. Right? The only thing I'm going to say about HTTP right now is that HTTP is going to be the stuff that the truck carries. So there's the highway. There's the highway, then there's the trucks on the highway, and then there's the messages or the load that's on the trucks. Right? There's this kind of like stack situation. Right? In fact, when you talk about networking, something that you're going to hear a lot is the stack, right? Or the networking stack, right? As we're getting more and more abstract, right? Further away from that copper wire. As a web developer, you're often going to be working very high up, but today we're going to look a little bit lower. So at a conceptual level, does the idea of IP, TCP, and HTTP, like do the relationships between these things, are they feeling, they should still be cloudy, but are you seeing some relations between them? Cool. And Calgary is not setting. Cool. So with TCP, we might as well just straight up start by actually coding this thing up, so you can see this stuff in action. TCP, if TCP is this protocol that allows messaging to happen between two actors, I'm going to need a system that can receive and send TCP messages. A lot of the time when we're talking about networking, we'll be talking about servers and clients. Right? Also, heads up, all these notes are going to be like formatted when I send them out to you with like extra explanation and all that. Servers and clients. And the idea of a server and a client is going to be very similar to kind of what you imagine it would be. A client is someone who asks for something. What would a server be? The provider, right? So the server can receive requests, right? Can process requests, and is also able to send out information, right? Or provide, like you said. Is able to provide. In TCP, a client is able to send messages to the server anytime they want with TCP. And the client is able to just show up and just say things. And in TCP, the server is able to send stuff to clients anytime they want. So the server can, it's like, say you're at a restaurant, and a server at the restaurant just shows up, and they're like, "Oh, you want a pizza? All right." And they just put a pizza on your plate. The server can just come up to you and give you things in TCP. Right? So provided that there is a connection or an established connection between the client and the server, they can have this back and forth communication that's just open. So once a client and a server are connected. Right? So again, very similar to maybe walking into a restaurant. Right? I can't order something from a restaurant until I'm in it. Right? I need to be in the restaurant and be like, "Oh, I want a salad." I'd probably say it a little nicer than that, but can I please have a salad? If I'm outside of the restaurant, I can't do that. Likewise, I need to be in the restaurant for a server to come ask me something or give me something. I'm not often just kind of on the street and somebody shows up dressed like they work at a really fancy Italian restaurant. "Hi, would you like some breadsticks?" Like, I'm not at your restaurant right now. I can't have that stuff. So the connection needs to be established ahead of time. So what we're going to be coding is both of these parts. We need to code up a server that is able to listen for connections. And we're also going to need to be able to code up a client that can create connections. I already have some examples here, some files. One's called client, one's called server. I'm going to make a folder called old. I'm going to drag all that stuff away because we're going to do this from scratch. Move. So what we're going to be working with today is a package or a module that's already built into Express, or not Express, that's built into Node, which is called net. I can go straight up into the REPL with Node and go const net equals require net. I mean, it doesn't give me an error, which is cool. I recommend hopping into the REPL and just trying out weird things like const blah, 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 and it gives me an error, right? And here I know that, okay, well that means if I didn't get an error when I tried to bring in net, that means that net is in there. And when I try to bring in something that doesn't exist, then it throws me an error, right? And right there, I've learned something new. So net is something. This is net. This whole thing. What kind of thing is this? Some sort of object, right? Some sort of object. Right? Some sort of object with all kinds of stuff in here, all kinds of functions, right? Whatever the heck a socket is, we'll find out. So it's some kind of object, and we're going to be playing around with the stuff that's inside of that object. I think that what we'll do is we're going to start by making a client. Right? We're going to make a very simple client, and we're going to make a very simple server, and then we'll take a break. And when we come back, we'll dive into coding like a whole bunch of stuff. Does that sound good? Cool. So here's my client. Client.js. Cool. I like to start off by just throwing in a good old console log. Hey, it's your boy. And we'll see if it does anything. Cool. I just wanted to make sure that I've got everything running properly. I've got my hey, it's your boy coming out. That's all good. What I want to do is I want to bring in net. I want to bring in net, and ideally what I want to do is I want to start creating my servers and my clients. So for my client, so this is the code that we're going to be writing, and I'm going to be writing it line by line. But just so that I don't make any typos, I'm going to keep it open for myself in a separate tab here. In fact, we're going to do this. Oop. So this is our goal. Right? And I'm going to be writing up bits and pieces up here. We're going to go straight to const client equals, I'm going to go net.create connection. I'm just going to do this. Just net.create connection. When I run my code right now, it breaks. And, yeah, there's an unhandled error. Address not available. I didn't give this somewhere to connect to. And if I went online and I looked up net create connection, so create connection. So the create connections function is going to need to receive some options. Some options which are required. And so I didn't pass it any options, so it gets angry at me. So I'm going to go ahead and I'm going to go back to here, and I'm going to give it some options. And my options are going to say, okay, I want to connect to some machine. And that some machine is going to be the host. I could say that my machine is localhost right now if I wanted to. And the other thing that I actually need to do is I need to say what port I'm connecting to. So when we're talking about networking, right, we'll be able to to connect to a machine, but is a machine only able to talk to one other machine at a time? Like, are you only able to have one website open at a time on your computer? Right? It's not maybe the best example, but like, we're able to have many connections coming to our computer at a time, like many. And the way that gets facilitated is it gets facilitated through these things called ports. So I'm going to go and draw this somewhere. Is this the one that I wanted to use? Decide later. Nope. Yeah, sort of. So here we're going to have our machine. That's machine A maybe, and this is so machine A, and this might be machine B. And if I had them just straight up directly connected like this, what's going to happen is that then if I had a machine C that wanted to be connected as well, then it can't, because like if machine C wanted to be connected to machine A, I can't because machine A is already talking to machine B. So instead what we come up with is we come up with this idea of many little, we're going to use these rounded rectangles. Many little ports, many little windows that people can use to talk to machine A. So that machine B might be talking to, whoa, machine B got really big there for a sec. Machine B can talk to, what? Oh, there you go. Machine B can talk to machine A through this port. And maybe machine C can talk to machine A through that port. And I might even have a machine D, which can talk through that port over there. And so ports are going to be like little windows, right? Little windows through which a machine can listen. Now, if machine A is like, it has a connection through this port here, which I might call port 2, and maybe this one's port 1 and this one port 3, right? I can't have other machines connect to I can't have other machines connect through the same port, right? Machines can only talk through the one, I don't know where that arrow came from. Machines can only talk through a single port, and a port can only handle one connection. So our machines are going to have thousands of ports. They have how many ports do we have? Not in Nigeria, but how many ports do we have networking? 65,000 ports. You're going to use all of them, maybe not. What does that mean? Well, it means we can pick really any number we want between 1 and 65,535. I would just pick some random 4-digit number, just random. So I can, on my client side, say I'm connecting to a machine and then define the port that I want to talk to. So random number 1337, right? Completely random number. Now, when I set up here and I go node client, I still don't get the connection working properly, but the thing is, there's nobody on the other side to listen to me anyways. Okay? So I'm going to need to set up somebody on the other side who listens. That other side is going to be my server. So I can go ahead and I can make a new file called server.js. And my server file is going to be similar. Const net equals, and this one's still also uses the net module. What I do with this one is I actually use a function. So let me hop into Node here. When I bring in net, so net actually has a function in here called create server. And that's what I'm going to be using to create a particular server. I want you to see what happens in my terminal when I go net.create server. Okay, so net.create server, that command here, when I pressed enter, it gave me all of this stuff up top. What is this thing? What kind of thing is it? It's an object, right? Specifically, it's a server kind of object. You're going to find out over the course of learning JavaScript, so over the course of the next couple weeks, there's objects, and then there's objects that have a particular type. Right? This here it's an object, but it's a server object. So it's going to have some extra stuff in it, right, that's already set up for server type object. For example, a server kind object, it might have a domain, or it might have connections. Right? So I'm able to actually create that server, and I'm able to save it in a variable. And that's what I'm going to do in my script, is I'm going to make a server, right? I'm going to save it to a variable. So right here, we're going to go const server equals net.create server. And what I'm going to say is that the server needs to listen on a particular port. So the server is a program that runs on my machine. And we can attach programs to particular ports on the machine. I can pick any number I want here. What should the number I pick be? 1337. So the port that my server is running on and the port that my client listens to need to be the same. Right. So 1337. And I can go ahead and save. And what I'm going to find now is when I go node server, what's happening? It's listening. It's hanging. Right? We use the word hanging. It's just waiting. Right. It's waiting. And when I open up maybe a new terminal and I go node client.js, what happened with my client? Yeah, it didn't throw any errors. And my program is still running. Like, I'm not back in my terminal. I can't ls. I can't do things. You know what's really funny is I can't control C. Oh, no, I can. Cool. No, that's good. In a minute, like when we come back from the break, I'm going to turn off control C, and it's going to get really annoying. But what's happening is that my server and my client are connecting. They just don't have anything to say. This is kind of like if you call someone and you don't really have it, you're just like, all right, and you just breathe, and you're just breathing. That's what this is right now. So I could maybe have it so that every time the client connects for the first time, my server might say something in the terminal. Right? My server might say something in its own terminal. And that's the last thing that we're going to do before we take a break. Or I'm going to write something like server.on. So on is going to be a function that I can use with my server. And what it's going to let me do is it's going to let me say, anytime there is a connection to my server, here is what I'm going to do. Right? Now, I know you might have peeked at the code that was on the right side already. But how would I attempt say something like, whenever there is a connection, here is what you should do. For example, every time there's a connection, I want it to console log new connection, right? What kind of code would I need to write something like that? So I might write something like if, and then connection is true, right? Then I might go console.log new connection. Right? The problem with this is that my code runs from top to bottom, and then when it gets down to the bottom, server listen, that's where it hangs. But it would only run this code here once if connection equals true. It would only run it once. And I don't want to just run it once. I want it to run every time there's a connection. I might need a callback, right? So this is where callbacks really start making sense, right? Because this is where callbacks are needed in JavaScript. Because the thing is, I have some action. Console log new connection. I don't want it to happen right now. I want it to happen later. So I might say, OK, here is what you do after connection. Right? It's a function called doAfterConnection, which doesn't happen yet. I can say, here is what doAfterConnection is. So here's what doAfterConnection is. And I should just trust. I should just trust that the server will run this function anytime there's a new connection. I just need to trust. Right? I don't see, personally, I don't see anybody going doAfterConnection with the parentheses. I don't see anybody running this code. Right? So a callback is going to be used when I want to give control to somebody else. Right? I have a function. I'm not the one running it. And I give it to someone, and they're going to run it when there's a connection. Does that idea make sense? Right? So I would recommend, if you still feel a little hazy about callbacks from last week, this is where you should maybe take a look back at the stuff that you did last week and see how it connects to what we're doing today and forward. Right? The main reason that callbacks exist in a language like JavaScript is because we need to handle this kind of stuff. And the word that I'm going to use here, is asynchronous stuff. I think that's actually what yesterday's lecture was for, right? The async control flow with callbacks. Right? There we go. So when I run my server now, so I need to start my server first. Then I'm able to go and start my client. And what I'll notice is when I go to my server, I've gotten new connection. And every single time that I stop and start my client, when I look over at my server, it will have said new connection every time. Right? And this is whack. Like, we have connections happening between two different programs. Right? And what we're going to do after the break is, and I'm going to try to get this to work for Calgary. I haven't been successful in getting the demo to work from your end. But what I want to happen is, y'all are going to have the code that I've written, and you'll be able to run the client and be able to talk to my server. Right? Again, we're going to see if I can get that to work for Calgary. It might take a little bit of finessing on my end. Sound good? Cool. Are there any questions at the moment? What does HTTP stand for? You're going right. All right, sure. HTTP is going to stand for the Hypertext Transfer Protocol. Right? And we will talk about this way towards the end of the lecture today. IP stands for Internet Protocol. Yeah. How many ports are already used? So the question for Calgary is, how many ports are already used? That's a great question. It kind of depends on what you have running on your machine. So for example, right now, I have a thing called, I have Postgres running on my machine. And Postgres uses a particular port. If I didn't have Postgres running, then I'd have one more free port. The number of ports being used already depends on the software that you have installed. So if you have like video games or whatever already on, they might be using some ports, right? Chat apps might be using some ports and all that. To really see who is using what port, there is who is using what port. Mac. There is a command, netstat. There you go. So there's a command called netstat or lsof. Yeah. Which lets you see nope, really not. The lsof should print out basically like a list of all the netstat. Prints out like a list of everybody who's currently using different ports on my machine. And it shows you like these are all TCP connections or whatever, and UDP, and whatever stream is. So there's a lot. There's a lot of stuff in there. I haven't used netstat in a while, but I feel like maybe this is the port number. I could check by running my server. So let's say I started my server, and I know this is running on. Oh, server was. I know my server is running on 1337. I could run netstat again and see if I see 1337 anywhere here. I don't at the moment. But maybe I think netstat shows us who's listening on a port on your machine as opposed to who's communicating through a port. I'll do a little bit of research while you're on a break, and I'll show you when you get back. And then there were no questions from Calgary. So we'll start up again in, let's do 12 minutes, maybe 13. Right, so at a good 11:15 for us here in Vancouver, 12:15 in Calgary. Cool. Hey Calgary, if I could get a thumbs up or something, just let me know that you're on the line, and we'll get started. Oh, my computer is frozen. Nice. So I don't know if did Calgary message back already? No? I mean, that's good, because... Yes? All right, cool. Yeah, my machine is completely frozen, so we'll turn this off for a second. I'll just bring it back up for a sec. Oh, good game.
So what if you try to like create a port that's already in use?
We could actually try that right now. The question here for Calgary was, what if we tried to use a port that was already in use? So my,
Probably won't happen, but
yeah. Oh, sorry for bringing. You know what, Calgary? How about take another minute? Because my computer just is freaking out on me. I'm gonna figure out the situation. I will be right back. Ugh. It's restarting now. Oh, peeps. I'm just gonna grab my stuff. Oh, what happened? Oh, yeah. Just had to wait for my. Oh, whoops. Sorry for the slam. I had to wait for my computer to like restart for some reason. Right. All right, welcome back. So my computer should be hooking up again in a second. I don't know what happened. It just kind of froze and restarted itself. So we'll find out. Remind me later. Yeah. Cool. All right, so we're hopefully back. And then let me just get this put into their separate windows. So that, and then I had VS Code, so terminal, iTerm. Cool. So when we had left off, what we'd ended up with was we'd successfully gotten two programs to talk to each other. Specifically, I would be able to run my node server, and then I was able to run my node client to make a request somewhere. Now, during the break, what I was doing was I was trying to edit my client to make it so that Calgary would be able to talk to us as well using this thing called ngrok. I'm not convinced that I've gotten it to work. I actually have a feeling that maybe that's what crashed my computer. So we're going to go back to using just localhost and then 1337. Basically, the idea here was that I was able to make these connections, and every time I made a connection, I could look over at my server and I'd see that I have my thing printing out new connection. Now, Peter had the question of what would happen if I was to run my node server on a port that was already being used. I mean, we could actually do that by running the server in one tab and then going to another tab and trying to run the server again. And I get back an error, which is good. I'm not allowed to have two programs trying to listen on the same port. Instead, what I get is this error that says, when you're trying to listen, the address was in use. address is already in use on port 1337. So if I wanted to run my server, like I need to make sure it's not running on a port that's already running. Make sense? Cool. And it's a pretty good error that we get back to. Now, what I want us to do is, it's neat for us to have the connection set up, but I want to actually send messages back and forth. So that's what we're going to do. We're going to have to say, and maybe the server can send some messages to the client, or the client can send some messages to the server. And we can set this up in a couple different ways. I'm going to start by saying that maybe when the client connects, I want the client to send some hello world message. So over on the client, what kind of code do you think I would need to say that when I've connected, I want to send a message? What's that? Pardon? It might be similar to the server one. So over on the server one, I said something like, when there's a connection, here's what you do afterwards, right? It might be something very similar on the client side, where I might say, okay, well, the client, then when you've connected, or something like that, right? So it might be client on connect. Now, what I really like about VS Code is that it starts suggesting stuff to me, right? So maybe it's client on connect, and then maybe I can pass in something to do afterwards. I could just test this out. I could see what happens if I go console.log I connected. Right? And when I run my client now, so say my server is already running. So my server is running. When I run my client now, node client, I got I connected on the client side. Right? I want my client now to send a message. I want my client to send a message through the connection so that the server is able to print it out.
Maybe module export? No?
So what would I do with module export?
Export function to say something?
So that the server is able to? Nah, so rather what I want to try to do is actually have the client send some information. Right? So I could go ahead and I could Google it. And I could go, okay, client send net TCP node. It's just a bunch of words. And I might find some different examples. So for example here, node TCP client and server example. So this isn't exactly documentation, but rather just somebody wrote some code. And, pardon? So this is some stuff done with sockets, so maybe it's not exactly what I want to do. Here's a TCP client and server in Node. I could take a look at this, and what I might find, they're still doing stuff with sockets. That's not a good example. You might eventually find an example that Nima wrote. And the example that I wrote involves the fact that we can say client.write. So once you have this client, among the things that you have access to is the write method. So the write function is going to let me just send a bunch of information through. A connection, when you want to talk into it with TCP, we're going to call that writing. You can just write into it. So I might say when I've connected, I want to write a bunch of stuff. And when I run this now, I don't see anything happen. I don't see anything happen, and that's OK. And that's totally fine. I don't even see anything happen on the terminal, on the server side, because the server might be receiving this message, but I haven't written any code to say print out the message. So not only does my client have to send a message, but my server has to have some code that says, what do I do when I receive the message? I'm going to need to hop into my server, and I'm going to need to say something like, anytime somebody sends me a message. Now I want us to think about how that's supposed to be written. This is what we wrote when we wanted to say anytime somebody connected to me. Right? What should I write whenever somebody sends me a message? Yeah. Maybe something like server on and then receive message or something like that. The thing is, we don't just receive random messages. We receive messages from connections that we already have. Right? So it's not necessarily the server who's going to be just receiving random messages, but it's a connection that sends me messages. So what I actually have access to do with the do after connection, or whatever I wanted to call this function, is I can say, like, given a connection, here's what they would do. And in here, I actually have a connection dot on. And I can do stuff like when connection sends me a message. Now, I might have gotten the syntax wrong. But what I want us to think about is the server receives connections. And the server is going to keep a list of all those connections somewhere. And then the server gets to say, when this connection sends me a message, here is what I do. And that's the way I'm going to write this code. I have my old server stuff here, which I'm just going to keep open in a separate tab. And I want us to just look at part of this code right now, which is connection on data. So my server can receive a connection, and that connection can send me data. So I'm going to write that in a simplified version over here. We're going to be working our way towards that bigger thing. What I do is connection on data. And I can do stuff with that data. Right? Connection on data, well, in this case here, given some data, right? So given some data, I might console.log a new message from a client, and then maybe the data. Right? So this is my server code right now. It says that whenever somebody connects, I'm going to print out new connection, and I'm also going to start listening to that connection for whenever they send me data. And when they send me data, I'm going to say new message from a client with that data. The reason for this is because, like, maybe I want to check. I might have some code in here that, like, check who the connection is with. Right? Maybe it's a connection to somebody that I don't want to listen to. Right? And I could just immediately cut it or something. Maybe it's a connection to somebody who's really important, and I want to do a special kind of listen. Right? Having that code in here lets me write custom stuff depending on who I'm listening to. Right now, I'm just saying anytime a connection sends me some data, I'm just going to console log it. And I can go ahead now and I can rerun my server, and I can rerun my client. And what I'll see over on my server is maybe ASJ, or you know what, let's make this nicer, hello world. And when I run my client now, I expect to see hello world on the other side. And what I see is, oh man, no, please, computer. What I see is, there we go. Okay, as soon as I clicked the thing, oh, it's flickering all over the place, eh? Why? Okay, it's flickering still.
There you go. Don't move. Oh, you moved.
I swear, like, I'm a living Faraday cage. Like, I don't... Okay, so what happens is, what I get is, look at that, hello world. So nice, right? Pretty. That's exactly what I expected to see. Maybe not. I got back a certain number of, like, numbers and letters. It's like a hexadecimal message. A server and a client, or two machines, can like talk to each other through the wire, and they can just shout. But they might not know what language they're shouting in. Something that I can say on both sides to the client can say, I will be talking in this language. Or the word that I'm going to use is encoding, meaning this is how my letters are going to be formatted. And the server can also be ready to listen for particular formatting for the letters. So this is not necessarily a big issue. What I just need to do is I need to say that my client, so this here is that my client is going to be talking in this format called UTF-8, meaning my letters and my numbers are going to be your usual letters and numbers, not like weird binary stuff. It'll be like nice binary stuff. And then over on my server, I'm also able to say, on my server side that every connection, they're going to be talking to me in UTF-8. Ideally, it's something that we wouldn't need to write, but the thing is, there's going to be many different encodings for different like keyboards and stuff like that, or just different languages. UTF-8 kind of covers a whole bunch of stuff. But what we're going to see now is when I restart my server and I restart my client, and I check out my server, I got hello world. So we successfully got some message from one program over to another program. Right? Successfully, there's sent a message from the client to the server. And I might want to even do the same thing backwards. Right? Go from the server to the client. If I wanted to do the same thing backwards for the server to the client, the code for it is actually going to be really similar. Okay? What I might do is, arbitrarily, I've just decided that this is going to happen whenever somebody sends me some data. I'm going to send back, thanks for the data. Right? But I don't want to console log, oh man. I don't want to console log this. Yeah. I don't want to console log this. What I want to do instead is I want to send it through the connection. And I want to send it through the connection. And the way that I get to do that is actually very similar to the way that my client could write. I can go connection.write. And it's like the server and the client are like writing each other letters back and forth. Right? Just writing each other letters. And now my server, if I was to restart my server, anytime that a client sends it a message, the server sends a message back. Why don't I see the message printed out on the client? What's that? Yeah, so the server sent a message back, but why am I not seeing it?
The client doesn't know what to do.
Yeah, the client doesn't know what to do, so I need to physically say when the client receives a message. So client.on, and there's going to be a client on data. It's been black? Has it been black for a while? 10 seconds. Oh, all right. Let's try a different cable. All right. Cool. Not black. Calgary. looks like the view's working for you again too. So over on the client side, I'm going to need to say client on, and then turns out there's a client on data, and I might be able to do things anytime the client receives some data. For example, console.log, a new message from the server, and then maybe the data. So now when I run my client, why did my font get weird? No, it's like it's aesthetic, but okay, all right. There, we're just gonna trash that other one. Now, whenever my client sends a message, it also receives back some data. Right? So we can set up all kinds of communication. Now, I have set up communication to work when I'm like connecting, right? When I'm connecting, but I could also set communication to work when I do some action. So one of the things that you did yesterday was you were listening for like user events, correct? You were doing like a typing and stuff like that. I think Travis did a keyboard thing, right? Or like a typewriter thing. So we could do something similar. I'm just going to paste in a bunch of code that's very similar to what you had yesterday. And what I get to do is I get to call client.write. I get to call client.write on things like pressing enter and stuff like that. And so then my client.write doesn't necessarily have to happen inside of Connect. It might happen in other places. So I could go over to here where I have in my old client. Let me just pull that up. Cool. I have this like old thing that I worked on. I'm going to work you through the code a little bit, and then we'll write it up. The basic idea is that I need to bring in the standard in module, just like you did yesterday, or standard in stuff, just like you did yesterday, and make it listen for my input. Standard in resume is, I think it's a configuration that like makes it work until you press enter. Like it'll listen until you press enter, and then it'll grab the text. We're setting standard in to be talking in UTF-8, just like I have my client talking in anyways. Where'd it go? My client in UTF-8. Again, there's other things like ASCII is another encoding, but we're going to go with UTF-8 today. So this is the first little bit of stuff that I'm going to do over in the client up at the top. And the reason I'm doing this is so I can build up some kind of like little chat app. So I'll be able to write code and then press enter, and it'll be when you press enter, it goes client, right? Or ding, yeah. Then this code here is very similar to what you have for your, let me get rid of a bunch of comments here. It's very similar to like what you wrote yesterday. Anytime standard input gets some data, which is going to happen anytime somebody presses enter, it'll check to see whether that data is like \q. That's for quitting. Otherwise, what it'll do is it'll console log the data, and it'll also client.write the data. And, I don't even need the control C stuff. I don't think. Should I? Nah. So over on my client side, really at any point that I want, but I'm probably going to do it, I think, right here. I'm going to say anytime that standard in again gets messages, it's going to client write that data. And I'm going to keep the client write hello world here just for fun. And now what happens is when I start my server, or rather when I start my client, my program's just still waiting, and I get to do things like sup and press enter, and my server says thanks for the data. And hello. And my server says thanks for the data. And each one of these messages is being sent to my server, right? New message from a client. And each of these messages is being sent to the server. And so I think what we're going to try is, in a second, I'm going to give you the code for this. Unfortunately, I think I wasn't able to get it to work from the Calgary side. It only works inside of this network. But you're going to get access to the server side code and the client side code like right after the lecture, so you can run it yourself as well and see how it works. I'll walk you through the basic steps for how it works, though. If I wanted to give somebody else access to this thing, is I can give you my IP address. So my IP address, and I find it in my settings. So if you're on a Mac, it'll be up in your Wi-Fi, and then network preferences. And then once you're there, you get to click on advanced. But there's like a billion different ways to find it. You could Google what your IPv4 address is. And then once I have my address, what I can do is I can take that and put that in the client instead of localhost. And so now whoever's on this network, if they were to run this code, they would be connecting to my computer at port 1337. And I could try restarting my client again and see that it still works. Hello. And my server is still receiving those messages. So if you were to take this program, and I'm going to give it to both Calgary and Vancouver. Calgary, this is for reference so that you can see what the code looks like right now. But it won't work if you were to run it. But over in Vancouver, say you did take, and could one person just try this? Take the code that I've pasted into Slack, make a new file, like a new node file, and just run it. You should be able to start chatting with my server.
In the VM?
Yeah, you could do it in Vagrant, yeah. So just make a new file called something like client.js or chat.js or something. Save this in there and then just run it with node client. And the communication should start happening. So I'm going to keep my server open here. Let me know when it's running. And we'll see if that works. Sweet. So I got was that you? Yeah, hello Nima. And now my machine's just talking to me. Right. So the way that the client is set up right now is that you're not receiving, you're not receiving any messages back from the server with the chat. But I could change my server. I could change my server to do something like, whenever somebody connects, I could send messages to everyone. Like I could echo back messages. So for example, instead of sending connection.write data, what I might want to do is anytime there's a message from a client, I want to send that message to everyone. Right? How would I send the message to every connection?
Declare them all as clients from
I need to keep them somewhere, right? Yeah, I need to like declare some place where I can store all my clients. So for example, I might have something like a const everyone, which is an array. And something that I might do is anytime there's a new connection, I might go everyone.push that connection. So that way I have an array of all of my different connections. And then something that I could do is anytime there's data, I could loop through everyone. So for client in everyone, then I could message each individual client. Client.write, and then message, and maybe the data that came through. So what I'm doing now is I'm not just echoing back thanks for the data. I'm writing to you the data that I received. So the server is receiving a message from one person, and it will send it to absolutely everyone. And so when I start, I like the emoji in there. Can I send emojis? Yeah. So when I start my server again, I want you to restart your client. So you'll be able to Control-C and then just run it again. And what you should start seeing is, nice, client.write is not a function. That's because this is for of. Little mistake there. Okay, let's try restarting the client again. Nice, another error. Unknown encoding. Hello world. So buffer.js. Let's see. We could figure out where this error is happening. Generally, what we can do is find the one line that I wrote, which is line 19, and see that apparently that's in client.write, and then this. That's because client.write does not work like console.log, where I'm able to go stuff, comma, other stuff. Client.write is only able to take a single string at a time, so I would need to go like that to concatenate them. So I just made a little flub there. So we'll try this again. And now whenever people send messages, is somebody sending messages right now, I guess? No. You got 3 connections. Yeah, now when people say test, does a message come back to you? There we go. Right, and now you see the messages coming back. And to show you here, if I was signed in as a client, every time I send a message, hey, I get a message from the server, and other people can chat to me too. I love TCP. Cool. TCP is this very bare bones thing that lets communication happen between 2 systems. One of the things that I want you to see from here, though, is TCP is very much like the Wild West. I need to do a lot of work on my own. There's very little rules. I've got to set up all this stuff just to send a couple little messages. And on top of that, there's the trouble of if I wanted to receive some data, if the client wanted to ask for some data, I would need to write a whole bunch of code that says something like, the client writes, hi, can I have some data? And the server is going to need to listen for somebody saying, hi, can I have some data? Go fetch it and then send it back. And it's a lot of work for us to code all of that. So while TCP is great for setting up things like little chat servers, it's not very good for setting up bigger websites. Specifically because the communication that we have between these systems is going to have to be pretty in-depth. It's going to have to be pretty complicated. Most of your job as a web developer is going to be working with asking for big amounts of data, right? Or asking to do particular things to data. For example, I need to get a user, or I need to get a user's friends, or I need to delete a user's post. Right? There's like things that we need to do with data. So on top of TCP, we can add an extra set of rules. We could add a whole extra set of rules where TCP is rules for how to use the medium, for how to use like the wire. HTTP is going to be a set of rules for how you use TCP. So HTTP, or the, where we go, lecture, HTTP, also known as the Hypertext Transfer Protocol, is going to be a set of rules that say, hey, with TCP, you can only, and this says, you can only make requests as a client, and the server listens for requests. That's the server. And then the server replies. So HTTP is again just the set of rules of how TCP can be used to facilitate communication. And it says a client asks for something, and the server replies. Right? Ask and then reply. So HTTP, which you're going to be working with tomorrow and onwards, is built up of these protocols of how you can format these requests and these responses. For example, even though I've made a TCP connection to localhost 1337, I can still add extra information to the end of that connection. Right? So HTTP says that I'm allowed to add, for example, /users. Right? I'm able to go, here's my TCP connection or whatever to localhost 1337, but I'm also adding extra information. And on top of that, with HTTP, I get to add extra information to my message, not just a bunch of text, but a bunch of text that's formatted to say, I want to get the, and then the users. Right? So if we were to think about things as, again, the that like a highway metaphor, the highway itself is the internet protocol. You don't really care about how the highway is built. You just want to drive on it. You drive on the highway with TCP. Right? TCP is going to be your trucks. And then TCP itself, you get to store information into a TCP message that's formatted a particular way. That's going to be an HTTP message. Right? And on top of that, HTTP says a client can ask and the server can reply. In HTTP, a server can't just come up to you and give you things. You need to ask for it first. Right? So that's something that you're going to notice when you start working with HTTP tomorrow and onwards, is it's going to work a little bit differently than TCP today. With TCP, we're doing something that's called duplex, full duplex, meaning both agents are able to talk to each other anytime they want. Yep. And like I said, I wasn't sure if I wanted to show you HTTP in action. I don't think I will. There's an entire, there's actually like 3 whole lectures on it, so I'll let that happen there. And in summary, TCP lets us communicate between clients. Is it the only method? No. There's also a thing called UDP, if you wanted to look up what UDP is. That's a thing. Right? But we're just going to be working with TCP in bootcamp. Now, I've built up this like little chat client. I'm going to give you the code for it. Your activities today are going to be actually like somewhat similar, except instead of chatting, like setting up like a chat client, what you're going to be doing is you're going to be setting up messages that are sent to our like snake server. So there's like a snake game where you control your character or your snake by sending it messages like up, down, left, and right. Right? So you'll get experience building up exactly what we built today over the course of the activities. Conceptually, does TCP make a bit of sense? Right? Cool. HTTP is going to be a big breath of fresh air when you realize that TCP just requires a lot of work to get the minimal amount of stuff done. And, HTTP is going to be a lot more fun. Cool. And yeah, I think that's about it for what I want to talk about today. Are there any questions? Cool. Are there any questions from Calgary, or could I get a no? And then I'll let you go. See, I could just call somebody out. I don't know if Mike's a student. We're gonna go. Lucas. Oh, Alyssa said no. All right. No questions. Cool. Well, then in that case, have a great rest of the day. I'm going to be sending you the notes in just a minute. And then, yeah, if you have any questions, please do just message me. And yeah, take care, Calgary. Have a great rest of your day, and same with Vancouver.